Cities rise, oceans part, stone defies gravity. And behind it all are people. Not just kings or architects, but laborers, mathematicians, engineers, working with what they had, in the time they lived, to build what no one else could imagine. This is not a list of the tallest, the longest, or the oldest. This is about the most ingenious feats of engineering humans have ever accomplished. The wall that stretched across empires, the dome that changed the rules of architecture, the canal that sliced a continent in half, the skyscraper that redefined what's possible. Each one solved a problem, reshaped the world, and told us something about who we are. And the best part? These structures weren't just built to impress, they were built to last. So if you've ever looked at a tunnel, a tower, or a temple, and asked, how did they do that? You're in the right place. Let's explore the boldest things humans have ever built, and what they still have to teach us.
Before we dive in, please quickly hit the like button and subscribe to our channel. Your support makes a difference, allowing us to keep bringing you fresh, exciting content. Plus, it helps our community grow. Thanks for being part of it.
At first glance, it's a wall, but really, it's a continent-spanning machine. The Great Wall of China stretches over 13,000 miles, built and rebuilt across 2 millennia, from the 7th century BCE to the Ming Dynasty. Why? To protect an empire, to organize trade and taxes, to show where civilization ended and chaos began. Built by soldiers, peasants, and prisoners, the wall used whatever material the terrain offered: stone in the mountains, rammed earth in the valleys, even rice-based mortar in some sections. Entire villages uprooted, thousands perished, but what remains is a structure engineered to endure. This wasn't just defense, it was psychological warfare in stone, a message to outsiders and insiders alike: we will not be moved. How do you keep a city of 1 million people hydrated? Without pumps? The Romans figured it out. Starting in 312 BCE, they built over 11 major aqueducts, carrying fresh water from mountain springs into the heart of Rome. They relied entirely on gravity. Each aqueduct descended by just a few inches per mile, enough to flow, but never flood. They engineered tunnels through mountains, built bridges over valleys, and even created siphons to cross dips in the terrain. Some still work today. They fed public fountains, bathhouses, and private homes, and by providing sanitation and water, they extended life expectancy and public health in ways unseen elsewhere in the ancient world. Before the flush toilet, the Romans built a system so advanced, some modern cities still struggle to match its efficiency. In 537 AD, in what is now Istanbul, the Byzantine Empire unveiled the Hagia Sophia, a structure so bold it rewrote architectural physics. Its massive central dome spans over 100 feet, floating atop a square base with no modern reinforcement. How? By inventing something radical: pendentives, triangular architectural elements that bridge a square base to a circular dome. Engineers Anthemius and Isidore used brick, marble, and precise geometry to balance the entire structure like a giant stone parachute. For nearly 1,000 years, Hagia Sophia was the largest enclosed space on Earth. It survived earthquakes, regime changes, and conversions from cathedral to mosque to museum, and back again. It didn't just shape religion. It reshaped what humans thought was possible with space and light. At the dawn of the 20th century, the US faced a shipping problem. Getting from New York to San Francisco required a 13,000-mile detour around South America. The answer? slice through Panama. But cutting a canal through dense jungle and mountainous terrain was a nightmare. The French tried and failed. Then, the Americans took over in 1904 and changed everything. They abandoned the idea of a sea-level canal and instead built a system of locks, giant water elevators that raised and lowered ships as they crossed the isthmus. It took over a decade, cost more than $350 million, and killed over 25,000 workers due to disease and accidents. But when the Panama Canal opened in 1914, it revolutionized global trade, saving billions in shipping costs and reshaping geopolitics. It wasn't just an engineering marvel. It was an act of geographic defiance. Dubai wanted a symbol. What they built was the tallest structure in human history, the Burj Khalifa, at a staggering 2,722 feet. Built from reinforced concrete and glass, its design is inspired by the hymenocallis flower, with 3 petals forming a Y-shaped footprint for balance and wind resistance. The concrete was mixed with ice flakes to withstand desert heat. Pumps pushed the mix 600 meters up, a world record. The building contracts and expands daily with temperature shifts, monitored by a central control system. And beyond its record-breaking height, it set a new template for urban vertical living, housing offices, hotels, restaurants, and residences within a single vertical city. The Burj isn't just a skyscraper. It's proof that even in the 21st century, humans are still chasing the sky. The English Channel once stood as an impassable moat, a 31-mile stretch separating Britain from the rest of Europe. Then, in 1994, we went under it. The Channel Tunnel, nicknamed the Chunnel, became the longest undersea tunnel in the world. It required boring machines to dig 3 parallel tunnels, 2 for trains, 1 for maintenance. The 2 ends, one in England, one in France, met in the middle with a margin of error less than a few inches. To manage pressure, temperature, and safety, the tunnel is lined with high-tech sensors, fireproof walls, and constant airflow system. It now carries over 20 million passengers a year. An entire ocean once divided 2 nations. Now you can have breakfast in London and lunch in Paris without ever seeing the sea. We think of engineering as wires, concrete, steel, but the greatest marvels are more than that. They are stories of risk, ambition, sacrifice, and vision. They challenge what was possible in their time and still challenge us today to think bigger, smarter, and bolder. From walls meant to divide to tunnels that connect, from ancient stones to modern glass, the legacy of human design is not just in what we built, but in why we built it. So ask yourself, what will our generation build that future humans will marvel at? If this video made you pause and wonder, hit the like button, subscribe, and drop a comment. Which engineering marvel would you want to visit? Thanks for watching. That's it.